In this video, we'll be doing another problem involving linear and angular speed. The formulas that we've learned so far for linear speed, velocity is equal to the distance along the arc of a circle per unit of time. Velocity is equal to the radius of the circle times the measure of the central angle in radians per unit of time. And velocity is equal to the radius times the angular velocity. Then our formula for angular speed, or angular velocity, is omega is equal to the measure of the central angle in radians per unit of time. Our problem that we'll be working with is a satellite traveling in a circular orbit approximately 1,800 kilometers above the surface of the Earth takes 2.5 hours for one orbit. Approximate the linear speed of the satellite in kilometers per hour, assuming that the radius of the Earth is approximately equal to 6,400 kilometers, and then also approximate the distance the satellite travels in 3.5 hours. So our first part of our problem, we want to approximate the linear speed of the satellite in kilometers per hour. So we can do the linear speed by using this formula. Velocity is equal to the radius of the orbit times the measure of the central angle per unit of time. So our Earth has a radius of 6,400 kilometers. And then our satellite is orbiting 1,800 kilometers above the surface of the Earth. So we need to find the radius of our orbit, and that's going to be 6,400 plus 1,800. So our radius is equal to 8,200. Then if we use our formula, velocity is equal to radius times the measure of the central angle in radians per unit of time, we get the velocity is equal to our radius, 8,200. And we know that one orbit is the same as 2 pi radians, so our theta is 2 pi radians. And then our unit of time is 2.5 hours. This gives us a velocity of 6,560 pi kilometers per hour. Then we're asked to approximate the distance that the satellite travels in 3.5 hours. Well, this is our speed in 1 hour, so we just need to multiply that by 3.5 to get our B answer. And so 6,560 pi kilometers per hour multiplied by 3.5 hours. This will give us 22,960 pi kilometers.